Hello, everyone. It's a great honor to have this opportunity to share some of the research on smart city planning to achieve balanced sustainability goals. I'm Zhao Yangdong from University of New South Wales, USW Digital Grid Futures Institute. Well, the presentation will cover the following topics, starting from background and the motivations of sustainable development goals. Then what is smart city and challenges in sustainability assessment, followed by smart city planning index framework and a smart city planning example and conclusions from the research. So starting from the background, why do we need sustainability development? It's very obvious in the past few years we are facing climate crisis and energy shortage. These are the two major challenges for sustainable development. So to solve this problem, the concept of a smart city was proposed as one of the potential solutions to have the more efficient utilization of the resources. And at the same time, if we look into the United Nations Sustainable Development Goals, there were 17 different SDGs covering, for example, elimination of poverty, tackling climate change, economic growth, sustainability, partnerships and peace, etc. Multiple goals to achieve for the SDG. Clearly, it's a challenge to achieve balanced development out of those multiple goals. So what we did, we're working with Mitsubishi Heavy Industries on this QoEn key index approach. Well, this index is developed by MHI, and the index indicates sustainable and balanced targets for energy infrastructure planners and investors. The beauty is that we're looking into this energy infrastructure development and its potential correlation and impact to sustainable development. So this methodology contributes to sustainable urban development using assessment frameworks through regular monitoring, cover social, economic, and environmental aspects. Now, we talked about sustainable development and potential solutions using smart city concept. I'm pretty sure you go around, you can find many definitions of smart city. So we just take one of the definitions here. A smart city is an urban area that uses different types of electronic Internet of Things sensors to collect data and use this data to manage assets and resources efficiently. Then objectives of smart city in our study here, we look into achieving a sustainable development, increase the quality of life of its citizens or residents, improve the efficiency of existing and new infrastructure. If we look into the figure on the right-hand side, we have environmental domain, economic domain, and social domain, and the overlapping of those domains corresponding to viability, livability, equitability, and altogether contributing to sustainability development. And this is from this reference book. Now, smart city is not just a concept. They reference the great, huge opportunities for future development. So according to this reference, smart city markets with perspective for 2016-2026 10-year outlook, the international market value for smart city is over $600 billion US. Well, given that the urban areas of the cities consumes 75% of natural resources, consumes 80% of energy supply, and generates 75% of carbon emissions. Well, for smart city planning, the many planning methodologies, here we looking into what we call integrated approach for smart community. So starting from individuals, if we look around what you have here, you may have wearables, you have smartphone and other sensors, other smart devices. So this is for individual. Then coming to home or building or an office, you have smart home, smart building, smart office. Then bigger coming to smart community, smart compound or smart campus. Then come to smart cities. Technology-wise, it will cover IoT, ICT technologies, the AI and data analytics, on the industry side, covering all the utilities, gas, water, transportation, health, and so on. But to more relevant to every resident of a smart city, we're talking about services that will cover health, security, people movement or transportation, and also energy and water. And what we're talking about is the asset management and town planning areas. You can think of different services and smart community or smart city to be incorporated into a smart city concept. Now, given the example here, so this is a typical example of a smart campus or smart compound or smart community technological solutions here. Starting from operations, these are the functionalities concerning the residents of the smart community or smart building, like security, alarms, fire hazard, and so on, and people movement, access control, healthcare. Then coming to vehicles, transportation, parking, radio, fleet management, then asset would be like data management, cooling, heating, energy, integration with BMS, and other asset management packages as well. So this is on the operational side. Then coming to one level further, come to data and integration, which is common depending regardless of different applications. Like IoT, you need a platform, you have cloud services, you have GIS if you want to graphical information, geographic information systems to show the maps and locations, and data integration, and also edge computing to conserve the privacy in data processing. Then these are backed up by things like data centers, ICT, communication infrastructure to support such data integration, monitoring, sensoring, and to implement the control of the smart actions to the smart community. Now here on the left-hand side, what I show here is smart city covers all the different aspects from small individual to building to home to large community to cities. One of the important concepts is that for a technology service provider, you could just say, take on the right-hand side figure, for example, this is a smart solution, give it to a building, to a community, that, right, it works. It is a smart solution. However, what we have here is human-centered smart city, right? Many of the functionalities, they are really good, but however, not every functionality are required. It depends on the needs, the level of development, and maybe economic constraints as well. So if we can, starting from the user, define what's needed, what's high priority, medium priority, low priority, and given the economic constraint, what will be available on the capital and operating cost to make sure the system works properly. Then you can achieve things, many benefits like capital deferral benefit, and also when you defer some of the technology later, they become cheaper and more powerful, more efficient. So when later on you need them, you have better services as well. But at the same time, it will be useful to have overall integrated planning so that you don't have to reinvest in something common like ICT, comms infrastructure, and so on. We have a number of papers published in the human-centered or human-led smart campus development for references. Now we look into, it's all good here, but there are many challenges in sustainability assessment. We can plan for the future, but there are many limitations. The key limitations are data availability, and once we have data, we have to do quantitative analysis and to check what ideas will be useful. And also there's a lack of general guidance on sustainability assessment framework for application in different regions, and insufficient correlation analysis between selected indicators and energy infrastructure development. Or in other words, we can do a smart city planning for a particular city, particular region. However, that planning, that platform, that methodology may not necessarily be applicable to another location. And there's no established correlation analysis to link the future scenarios on energy mix, energy development with respect to other sustainable development goals. Now, having this in mind, this is what we propose, what we developed here. To implement and organize the QoEn, key indicator in practical application, we proposed this three-tier story chart for the framework. So it's starting from 3 levels, from general level, which is a basic framework for connecting conventional wisdom with context in energy infrastructure. Then we come to the intermediate level with more professional knowledge involved, which at this level, we sort out the reasons behind why an indicator is selected and categorize those indicators into specific domains. And the third level, getting to more details, we can do data analytics and forecasting and other interpretation of the information provided. So we go through it one by one. From the general level, which gives a basic framework for connecting conventional wisdom with the context in energy infrastructure. In the table, you see 3 blocks. So we're starting from general feeling in the perspective of economic, environment, and society, coming to the impact by energy infrastructure, the general understanding, still common sense. Then you identify keyword in each impact. For example, under economy domain, what we have is sustainable and stable economic growth. This is something good, right? And also we want everyone to enjoy the benefit. Well, the factors are we need economic growth and we need reduced fluctuation in the development. And correspondingly, you need investment and you need stable supply. So these can be referred to as K index, as keywords for the next stage. Then after this selection, you come to intermediate level to find indicator in line with keyword. Then to detailed level. Let's see what's happening next. So the intermediate level, we sort of the reason why an indicator is selected and categorized into specific domain. There are 2 major blocks here in the table. So for each indicator, we can connect with high level with the keyword. Right? And we allocate into each domain by keyword. Again, it sounds very abstract, but we take example here. Like the first one, we have indicator which is demand side participation. Well, demand side participation is good. They're contributing to energy interdependence. So we classified it into society, right? But if we look into another indicator like rooftop PV installation, it will cover different domains. For example, it will bring income and reduce the electricity bill for the owners. So it covers economic domain and it contributes to emission reduction, so environmental domain. At the same time, it contributing to energy independence. So that's for the social domain as well. Then similarly, you can identify all the keywords and associate them to different domains. Then the keywords can be defined in domain, can be in one domain, 2 or multiple domains. And this associated data can be obtained. Well, of course, you have to check if they check the data availability. That's another factor in selecting specific keywords. Then finishing that level, we go to the detailed level, which is detailed analysis for each indicator. This you can incorporate all the research we are doing every day, like time series prediction, short-term prediction, long-term prediction. Here is more on the long-term side. You can think of econometric prediction and so on. So this is only one of the approaches here. The point I want to emphasize is that when we do prediction, it's prediction. It's not real. Things may change in the future. So we ideally, you do prediction with certain confidence intervals. But then you can have different scenarios, like high scenario, which indicate fast changing case. Medium scenario is the moderate changing case, or most probably to happen in the future. And low scenario, the likely changing case or conservative case. Then it's up to the planner to choose which scenario. And it also gives the appropriate risk measurement factor for the planners. Like, for example, you want to be very conservative on some critical areas. For example, hospitals or some other facilities, you may like to consider low scenario. But for some areas, most areas you consider medium scenario, and some areas you consider high scenario if it doesn't matter, like in some of the non-critical sectors. So having that, this is an example we obtained from different domains. You can choose different parameters, different indexes, depending on the data availability and following the 3 steps. Without going into any details, we have a paper published with all the details. You can refer to the paper, but just highlight here. For example, in society, you're talking about safety and health, job opportunities, quality of life, and so on. For economy domain, we're talking about new investment, cost effectiveness, effective energy usage, and so on. For environmental, there will be low pollutant emission, and carbon emission, low carbon emission, and support renewable energy, and so on. Then what we want to have some numerical indicator for easy reference and assessment. So to calculate the indicator score, a number of things we have to do. This is the first for the desired direction. So for an indicator, sometimes we want the indicator to grow in a positive direction. For example, we want to have a higher, for example, if we're talking about demand response, right? We want demand response to increase because it contributes to the benefits in the society side. So the desirable direction of change is positive. And also, if we're thinking about inequality, we don't want inequality, we want balanced development. So inequality should be decreased to achieve higher economic sustainability. As such, the value or the trend for inequality should be negative over the planning horizon. Now, this is another factor. We want the value to be normalized, so we use a weighting factor, simple weighting factor, as shown here. So dividing the number of factors in the domain. So for each economic or environmental or social domain, the indicator score is weighted sum of individual indicators. Now, once this are done, we're ready to go for the indicator. So this is a case study. We use the city, in this case, Western Sydney. As you can see, we selected 32 different indicators. They belong to economy domain, environmental domain, and society domain. Things like market value of distributed BESS, or level of electricity, electrification, transportation, for example. These are tangible energy infrastructure related indicators, and they contributing to the overall score. Now, this is what we do for after detailed analysis. You can get indicator scores for current status, future scenario, and target scenario. This is done through data cleaning, prediction, and further analysis. Well, still looks messy, although it contains very useful information. So here we come to the visualization of all these development scores. If we take more indicators here and different domain here, like economic domain, the first figure, you have all these indicators. So the corresponding, the current status, right? Current scenario unbalanced, as you can see some are well developed, some are less developed. Then the future scenario we want balanced, as shown in the green lines, and also future scenario are shown as red lines. More or less balanced, but still a lot of work to be done to make sure they are really balanced in the future. But this is still messy, not very straightforward. You have to read in greater detail to get the idea. So if we further narrow down this visualization process, we use this triangle diagram for case study, only looking at the overall scores for society, economy, and environment domains. So the current scenario, which is blue triangle here, it shows that economically is well developed, but in view of society and environment, still lagging behind. In the future, however, society and environmental development will be well advanced, but the economic development will be lagging behind, not meeting the balanced development goals. So what it tells for the planner is that the planner can look into this indicator on an ongoing basis. For example, every year or every time new policy or new investment being changed, then you check the indicator here, because the current scenario may change and future scenario may change. Right. In this case, for example, we may see that we need more economic incentive to ensure that in the future, as close to the planning horizon, the economic will be developed as well to benefit everyone. But at the near future, currently, more work should be done in society and the environmental domain. And this investment or policy preference should be adjusted along the planning horizon every year or every time when things change. So that is a simple but very effective approach of smart city planning to ensure balanced development. Everyone can understand generic 3-layer story chart to go to the details and to get a key index framework working for different regions, different areas. So the same concept, you can do the same approach, selecting appropriate indicators and use it for different city planning. So we provide, after the calculation, after the numerical analysis, it provides scientific evidence for decision-making on new infrastructure investment and policy-making towards sustainable development with respect to the energy infrastructure. Well, of course, the same idea, you can extend the work to consider other infrastructures as well. As I mentioned earlier, the work is published in some papers here. So the first paper is more on the key index approach. It's accepted to appear anytime in IET Energy Conversion and Economics. And the other two papers are our previous work on human-centered smart campus, smart city development, and user case studies. We published intentionally on those open source journals here, so more people can read and will benefit from it. Hopefully it will provide some useful reference for smart city or smart campus development. While the team here, we acknowledge the support from Mitsubishi Heavy Industries, and we acknowledge the work is partially based on MHI's concept of QoEn, K-index approach. And this QoEn and all related marks and logos are registered trademarks of Mitsubishi Heavy Industries Limited in Australia. Right, thank you very much for your attention. This is the end of my presentation. Thank you.